Right, there are two properties on an actor that are important when it comes to replication role and remote role. These two properties tell you who has authority over the actor and whether the actor is replicated or not. The first important thing to determine is who has authority over a particular actor. To determine if the current running instance of the engine has authority, check the role property as role authority. Okay, so for object ownership, you can check the do they actually tell us where the fuck? Role equals role authority. Alright. I don't see any code on this page where they actually show you where the hell you're supposed to get the role from. That's really annoying. Alright, to determine who has authority over a particular actor, to determine if the current running instance of the engine has authority, check the role property. Alright, so role. So role authority means we own it. If role is role authority and remote role is either role simulated proxy, the instance is in charge of re-replicating this actor to remote connections. Currently, only a server replicates actors to connect to clients. Only the server should be role equals role authority and role remote equals role autonomous. Yeah. Role and remote role could be reversed depending on who's inspecting these values. For example, if on the server you have this condition, alright, role equals role authority and remote role is remote simulated proxy, then the client would see role simulated proxy and remote role role authority. Alright, so you can check the role and remote role. Alright, so it's basically saying like role authority means that source owns the actor. If role, then we own it. So check our role and then check their role. Okay. So if it was something that somebody else owned, we would see remote role, simulated proxy, and our role would be autonomous proxy or some sort of crap. Server doesn't replicate actors every update. This would take too much bandwidth. Alright, don't tell me that. Just say it doesn't. Instead, the server will replicate actors at a frequency specified on the net update frequency S, so we know. There are currently two types of simulations that occur. Simulated proxy. This is a standard simulation path and is generally based on extrapolating movement based on last known velocity. When the server sends an update for a particular actor, the client will adjust its position towards a new location, and then in between updates, the client will continue to move the actor based on the most recent velocity sent from the server. So, replication modes, there is simulated proxy, which is interpolated values based on velocities, and autonomous proxy. This is generally used by actors that are possessed by player controllers. This means that this actor is receiving inputs from a human controller, so when we extrapolate, we have a bit more information. We can use actual human inputs to fill in the missing information. What the fuck does that mean? We have a bit more information. Doesn't tell me what it is. It doesn't tell me anything about what the hell the difference is. It just says we have more information, so we do special stuff. It doesn't say like we don't interpolate or any of that. It just says and it's different. And, well, good job, docs. You're super helpful in this. Alright, so we've already read RPCs, property replication, we already read that. Replicating object references. Generally, object references are handled automatically. That means is if you have an object property that is replicated, the reference to that object will be sent over the network as a special ID assigned to the server. The special ID is fNetworkGUID. The server is in charge of this ID and then notify all connected clients of the assignment. To replicate object references, you simply mark a UObject property as replicated. In this case, the owner properly replicated to the actor that his property references. For an object to be legally referenced over the network, it must be supported for networking. To check this, you call is supported for networking. This is generally considered a low-level function, so it's not common to need to check this in game code. In general, and this is an A actor. Alright. In general, there are guidelines to go by to determine if you can reference an object over the network. Any replicated actor can be replicated as a reference. Any non-replicated actor must be stably named, loaded directly from a package. Any replicated component can be replicated as a reference. Any non-replicated component must be stably named. Any UObject must come directly from loaded packages. Stably named objects are simply objects that will exist on both the client and the server and have the same name. Actors are stably named if they are loaded directly from packages. Components are stably named if they are loaded directly from packages, added via construction scripts, and manually marked setnet addressable. It should only be used when you know manually naming components. Alright, so there are things you can do for replicating object references, but read the docs if you run into problems. Alright, so multiplayer in blueprints. Unreal provides a lot of multiplayer functionality out of the box. Don't tell me easy stuff, just tell me what it is. Alright, the game instance exists for the duration of the engine's session, meaning it is created when an engine is started up and not destroyed until the engine shuts down. Alright, so let's just see game life cycle. Game instance exists for the duration of the engine's session. What the hell does the engine's session mean? Is created when the engine starts up and not destroyed until the game engine shuts down. This is the lifetime of the process, I'm guessing. A separate game instance exists on the server and on each client. These instances do not communicate with each other. Because the game instance exists outside of the game session, the only game structure exists is a good place to store certain types of persistent data, such as lifetime player statistics, account information, or even a list of maps to rotate through a competitive game. This should hold pretty much all metadata not specific to the network game. The game mode object only exist on the server. I'm gonna have to move some stuff around here. Game mode only exists on the server. It stores information related to the game that clients do not need to know. Alright. So let's diagram this out. Alright, so these do not communicate with each other. Alright, so for example, if a game has a special rules like rockets only, well, client may not need to know this rule, but randomly, alright, whatever. The game exists, alright, so game mode is also, is it level specific? The game state exists on the server and client, so the server can be used to replicate variables on the game state. So we have, then we have the game state. Server can use replicated variables on the game state to keep all clients up to date. Information that is of interest to all players and spectators but isn't associated with one specific player is ideal for game state replication. Example is a baseball game can replicate the other's score. Alright, yeah, okay. So game mode, we've got that. We have game state. And exists on client and server for game state. And is replicated from server to client. Can we send RPCs on that? So that'd be a question is, can we use RPCs in the game state object? Alright, so we have game state, and this is where stuff actually starts replicating. One player controller exists on each client per player on that machine. These are replicated between server and associated client, but are not replicated to other clients, resulting in server having player controllers for everyone. Alright, so I'm going to have another little stack here, which will have other client. And they've got their own game instance, and they've got a game state. And then we have the player controller. And this is, so player controller. And we do not replicate that over to the other client. Alright, player state will exist for every player connected to the game on both server and the clients. This class is used to replicate properties that all clients, not just the one that only the client are interested in, such as the player's current score in a free-for-all game. Like the player controller, they are associated with individual pawns and are not destroyed and respawned when the pawn is. Okay, so we have a player controller per thing, and then we've got a player state object. And we're going to have class use for replicated projects that all clients are interested in. Alright, so we will, so player state stuff will be there, and we'll replicate all the things. So let's just make sure to put that in our little diagram here. Alright, I'll write that down. Alright, so pawns will also exist on the server and on all clients and can contain replicated variables and events. This decision when to use player controller, the player state or pawn for certain variables depends on the situation, but the main things keep in mind the player controller player state will persist as long as the owning player stays connected to the game, whereas a pawn may not. For example, if a pawn dies during gameplay, it will usually be destroyed and replaced with a new pawn. Alright, so we'll have like player pawns. I should just call them pawns, to be honest. Like, Those are just actors, right? Alright, so replicates is tick boxes and all that crap. For every actor in the world, there's an authority, we know. Yeah, I think right now I've got like a whole bunch of crap set inside the game mode, and I actually need it inside the game instance. So I'm gonna have to keep my little list of notes of crap I have to do. So tasks to do. Move logic for all that. Move logic for global information into the game instance, as the game mode is only on the server. Let's see. Let's add some arrows to this thing. That's the direction for all the replication. Alright, so what else we got? Replication variables, there's like, you can set if something's replicated. Rep notify, the variable will be replicated as in the replicated option, but in addition, an onRep function will be created in your blueprint. Okay, so replication, there are onRep functions that you can implement in blueprints for replicated variables. So, can we do this in C++ land? Because that's pretty nice. When a replicated actor is spawned on the server, this is communicated to the clients, and they will also automatically spawn a copy of that actor. But since replication doesn't occur from clients to the server, if a replicated actor is spawned on the client, that actor will only exist on the client. Neither the server nor any other... Yeah, we get it. It will only exist on the client, and then they send the whole sentence saying the same damn thing again. The situation is similar for destroying replicated actor. If a server destroys one, all clients will destroy their copies. Clients are free to destroy actors for which they have authority. If a client tries to destroy an actor for which he does not, the request is ignored. Okay. Is there just a general notes thing here? What the fuck are my general notes? Overall notes. I guess I don't have one. If you try to destroy an actor you don't have authority over, it won't do jack shit. In blueprints, in addition to replicating actors, you can also run events. Important concept to note is owner. Alright, so they got a whole bunch of stuff we've already gone over. One thing to keep in mind when using replicated events to communicate game state changes is how they interact with a game that supports joining progress. Yeah, right. So if you don't receive the event, you won't know. So store that stuff in some other pattern. A pattern comes up pretty often as the client performs some action in the world and notifies the server. In the implementation of that event, the server updates some replicated variables based on the action. And the other clients who did not perform the action still see the results. Yes. In other words, change values. Use a strong system. Set a flag. Alright, replication can be reliable or unreliable. Cool. Character movement component. Characters using character movement will have client-server networking built in. Replicate move to server, saves the move, calls perform movement, replicates it to the server by calling replicate function. Okay, so the character move components has a bunch of networking stuff built in. I'm not using it, so I'm going to ignore this. If I have problems replicating crap, then I'm going to look into it more. To give a concrete example, replication. Alright, I don't need to go over an example. Networking overview. Already read that. Traveling in multiplayer. In UE4, there are two ways to travel, seamless and non-seamless. The main difference is that seamless travel is a non-blocking... What the fuck is traveling? Like, are we playing basketball here? When a client executes a non-seamless travel, the client will disconnect from the server and reconnect to the same server, which will have the new map ready to load. Alright, you're traveling. Like, what the fuck do they mean by traveling? It's recommended that EU4 multiplayer games use seamless travel where possible. Is this traveling between servers? Because we could have just said that in the header and just be like, we're talking about servers. Instead, they're like using traveling as a word that it has a very specific meaning, like it's jargon I should know, which is bullshit. They haven't defined it anywhere, so why would I know what the word means in the context? It's recommended that EU4 multiplayer games use seamless travel where possible. Alright, so seamless travel is non-blocking. Non-seamless will be blocking. Alright, so non-blocking of course means we're going to move to another server without freaking out. Okay, so this is traveling between maps. Okay. It's like a hard reset when loading a new map will always result in non-seamless travel. Will result in server disconnecting current clients before traveling to the destination map. Alright, so we won't... Like, this is just a really badly written article in my opinion. Because they're just using stupid words. So this is moving between, like, loading up new maps. I mean, it's obvious there's, like, people at Epic or whatever who wrote this, they're talking about, you know, specifically, like, Unreal Tournament or something, and they're like, well, this is traveling between maps, and all that trash. Okay, so loading up new maps on the server. This can be done two ways. Seamless and non-seamless. Those are just stupid names too. Alright, so browse. If you say browse to a level or something, it's like hard reset and loading a new map, will always result in non-seamless travel. Will result in server disconnecting current clients. Clients will disconnect from the server. Alright, we got that. Dedicated server cannot travel to other servers. So map must be local. Yeah, that makes sense. Like, it's a dedicated server, not a freaking client. Server travel. Will jump the server to a new world or level. All clients will follow. This is the way multiplayer games travel from map to map, and the server is the one in charge of calling this function. the server will call client travel for all client players that are connected. Alright, so on the world, if you call server travel, the server will load the new level and tell all clients to load their levels. On the player controller, client travel will be called to load a new map. If you are a client, you can travel to a new map travel to a new server. Okay. To enable seamless travel, you need to set up a transition map. This is configured using map settings transition map property. By default, this property is empty. Alright, so to enable seamless travel, make a transition map, set it in new game map settings, transition map. So we can have like a, by default this is empty, and if your game leaves this property empty, an empty map will be created for the transition map. Okay, so alright, you just, that's stupid. Like, you don't have to do this. Like, just basically, seamless travel uses a transition map. You can customize this with the UGameMap settings transition map property. That's really what they mean. The reason this exists is that there must always be a world loaded. If we can't free the old map before loading the new one, maps can be very large. It'd be a bad idea to have the old new map and alright, just there are reasons. So you can travel from the current map to the transition map, and then you can travel to the final map. So this transition map is very small, it doesn't add much extra overhead. Once you have the transition map set up, set a game mode base, use seamless travel to true. Alright. To enable seamless travel, set this to true. Set the seamless travel to true inside your game mode. Here's the general flow when executing seamless travel. Marked actors that will persist to the transition level, travel to that level, and mark actors that will persist to the final level. Okay, so you can transition actors from one level to the next by marking them for travel. When using seamless travel, it's possible to carry them over. By default, these actors will persist automatically. The game mode, all controllers that have a valid player state, all player controllers, all local player controllers, any actors added to the get seamless actor list. Okay, so you can add actors here. Some are automatic. So, alright. Alright, so online beacons are a special type of actor that provide a lightweight way to contact the server and interact with it without committing to a normal game connection. While the built-in classes can be used as they are in some cases, they are intended to be extended into custom classes to perform project-specific interactions, logic, and information. Common actions performed are the request quality of service, reserve a slot in the game, receive a list of names of players, find out the score, Alright, so you can get some basic info. The following classes are provided with the engine. Okay, so non-connected client interactions. So these are called online beacons. This is a base class for a beacon host. It is derived from a actor directly. This class uses its own net driver for listening. When it receives one, it looks through a list of registered beacon objects and finds them. Okay, so there are different types of beacon objects. Let's see, A online beacon, A online beacon client, A online beacon host object. Alright, so an online beacon is the base class. Beacon host, this class listens for connections. Well, why don't they just say it? It's on the server and it listens for connections from remote clients. When it receives one, it looks through a list of registered host objects to find one that matches the incoming client and hands the connection off to it. This client is not usually needed to be derived since it only manages the initial connection. This handles new clients getting host objects? I don't know what the hell they're doing here. Children of this, alright, the beacon client. Children of this class connect to hosts and make RPCs. One of these will be spawned on the client machine and won't be spawned on the server by the appropriate host object. Okay. Exists on the client. And one will be spawned on the server by the appropriate. Exists on the client. One is created on the server by the host object. So one per client or whatever. Makes RPCs. By default, the output of the getBeacon type function will be used to match instances of the class registered appropriate host objects. Note that this different from how actor spawning usually works, where the server spawns the actor. However, once the connection between the client and server's copy of the objects has been made, replication of the object behaves as normal, with either side able to make RPCs to the other. In the server's version, the object being authoritative with regard to property replication. Okay, so able to make bidirectional RPCs and allows server to replicate data to client. So, like if you had game state scores or something, it could be sent automatically. This class is the workhorse of the system and will do the client-side work that your beacon requires. Since a second instance synced with the original will be spawned on the server in the event of a successful connection, this class can also do server-side work. Alright, the beacon host object. This class should be overridden so that it can be paired with an overridden beacon class for the client. Pairing is accomplished by matching the return value of the client's type with the value stored in the name variable. Alright, so the beacon clients are mapped by name. So that'd be like a string name or whatever. It will instruct to spawn a local copy via the spawn beacon actor function. By default, this function uses the beacon actor class variable to determine the class of the actor to spawn, which should be set to the paired beacon client class. It also calls set beacon owner on the server's copy, so the server-side instance of the client object communicate with the host. Most of this setup is established in the base class and does not need to be opened. There are a variety of pre-made beacon class pairs. The test beacon is a good one. Alright, so For reference, look at the test beacon, at the A test beacon. Alright, so there's like, you know, test ping pong sort of stuff to make sure we can actually communicate. So let's see overall notes. Use beacons to determine QoS and connect quality of service for the client server interactions. So that's networking. That's everything. Okay. Didn't tell me what port things are on though. Oh man. So I need to somehow digest this information that I wrote down. So I think this is the big one, is this game lifecycle where we have the server, the game instance, the game mode, which is by the server, and then we have this game state, which gets replicated. So I need to figure out where the hell to own everything. Alright, so it sounds like what we're going to do is... How do we set the network mode? I guess network mode is just set at startup or something. So basically I think what we want to do is we want to set up a nm listen server. And then we'll be able to mess around with stuff. Alright, well, I have no idea where the hell to start. Jesus. Alright, so like I've got my game mode, and right now my game mode let me refer to my handy picture here. My game mode has the fucking UI in it? Yeah, that is ridiculous. All right, so the game mode here is controlling bad things. All right, so the game mode is server only. I need to just, all right, so that's tasks to do here. So move all the things out of the game mode and into the game instance, like the UI. That's really funny. So we have like the UI is on the game mode, which is only on the server, which is just hilarious because the server doesn't need fucking UI. But it looks like most everything else we've got properly set up on our game instance. Alright, so I'm going to also want to break out the game mode into another CPP file and segregate logic properly. Jesus. And now we boot up the editor for the first time today. After spending 2 hours reading documentation. Okay, so how do we actually, like, is it in settings or something? Like, project settings. Maps and modes. So we got our game mode set up, selected game mode, game state, player state, spectator class, global server game state mode. Oh, interesting. So there is, we can actually have a separate game state for the server. We need to create a separate game state for the server. Game mode map prefixes, game mode map, or game mode class aliases, editor startup, game default, use split screen, game instance class. I don't need that. Alright, that's fine. I need like more fucking monitors here. So this is maps and modes for that. Game mode is not specified per map. Dedicated servers, if not global default. Okay, so we can specify the URL. Let's see, cooker, crowd, gameplay, general settings, fonts, default classes, world settings, physics, asset manager, preview, new clip, smooth frame rate range, full streaming. No. Verify pure. Enable multiple world origin rebase. Whatever the hell that means. Physics rendering slate settings streaming. Async loading thread, event loader. Use background level streaming. Alright, so the question is, how do we actually boot up a server and then connect to it? Is there like a sample or a tutorial here which has something in it? Blueprints, decals, lighting, materials, game projects, multiplayer, shooter game, multiplayer shootout. Alright, so the simple multiplayer showcase is a game built entirely in Blueprints, an example of how you might use Blueprints session nodes to facilitate multiplayer. It has a main menu, server list, a simple map, click and play, online session nodes, and their implementation. Section discusses, alright, so open map folder and the main menu map. Standalone game, play this level in a window that runs as. Oh, interesting. So we can actually. I haven't really messed with this too much. Did it just crash, or why is. I mean, not loading? Man, that took way too long. Guess maybe it's a development thing. Man, it's quick. He's so tiny compared to the grass now. No. Ah. Number of players, run dedicated. If checked, a separate dedicated server will be launched, otherwise the first player will act as a listen server. Advanced settings. Level editor. Alright. Okay. Alright, so report gets HMDs, mouse controls, stream sublevels, play a new window. Server game options. Editor and listen server count as players dedicated server will not. Clients make up the remainder. Server game options. Run dedicated server. A separate dedicated server will be launched, otherwise it will act as a listen server that all players can connect to. Where do I set that we are like a listen server? Oh, that's what I want to know. Auto connect to server, route first gamepad to second client, use single process. Well, I guess we're crashing out now. I'll see if that has to do with something else. It's in the game instance. I've got some kind of hacky bullshit with some of these global variables. That's probably going to screw stuff up with this. Alright, if we just have one player. It works. Alright. So if we have 2 players. What was that horrible error? Something was big and red and ugly. Yeah, what is this? Access to non-trying player proxy. Look up and down. Event default skies. This platform is the one. So like shut down once and twice. On the second one we explode. So what is this thread stuff doing anyway? Yeah, so we need to get a game instance pointer to attach this thing. Let's see if we can fix this real quick. It looks like when we snag the thread for this thing, we need to... That's just not going to work. Yeah, we're registering this thing. It's like we're using it as like a global variable, but obviously there's multiple game instances that will be created here. So I guess we need to just save this thing on here. Well, let's just see if it works. Is it U objects? No. Pretty hacky. I should probably need to find a better way to deal with global variables for our game instances. Because right now, that's pretty trash. And if we've got two game instances running in the same process, I have completely screwed. All of this. I'm just looking at the multiplayer thing while this compiles. So for their basic game, the game instance is convenient place. There's also starting to play game itself, break down the game components. Alright, so it's set multiple number of players. I guess that's the number of players that can join, or is that the number of players that the editor actually boots up? Alright, so once you have a game hosted, with ping of 14, I can tell exactly why. That's going to be one frame, so that means that a lot of these, we're going to have like one frame of lag for all of our RPCs, is what it sounds like. Alright, I need to move this. I'm going to have to kind of set different things up, aren't I? I'm going to have to like attach something to the frickin' world or something that all these things can access. That'll allow us to. Because I need to know, like I basically want to get the game instance that we're in, and then so if I throw everything on the game instance, I figure out a good way to get everything. Put things where they should go. Anyway, let's see if this still explodes on me.